different positive integer factors. The question defines that 6 is not such an integer because 6 has 4 different positive factors, 1, 2, 3 and 6. So the first thing is we have to, I think to answer this question, I will quickly use method 1 for most of the people who know nothing about this concept of three factors. The easiest way out for you is just simply start writing down the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Write them till 16, 11, 12, 13, 14, 15, 16. It doesn't take much time. Just you can keep the time track. There is one factor, 2 has two factors, 1 and 2. 3 has two factors, 1 and 3. 4 has three factors, 1, 2 and 4. First number that satisfies the condition. 5 is two factors, 1 and 5. In number properties, we understand that every prime number will have exactly two factors. So after 5, the next prime number is 7. They will have two factors each. 11, it will also have two factors. 13 will also have two factors. So they are straight away out. 6, as the question already has mentioned, it has four factors, 1, 2, 3, 6. So it is out. 8 has again four factors, 1, 2, 4 and 8. So four factors. 9 has factors 1, 3, 9. So it has three factors satisfied. 10 has four factors, 1, 2, 5, 10. So it's out. 12 has more factors than even 6. So definitely out. 14 has factors 1, 2, 7 and 14. So 4 factors, out. 15 has again 4 factors, 1, 3, 5 and 15. So 4 factors, out. And 16 has more than factors that 8 has. It has 5 factors, 1, 2, 4, 8, 16. Therefore it's out. The only numbers that we get are 4 and 9. So if you are quick with finding out the number of factors of any number, I think you can answer this question. That's method number 1. Now let's talk about another method that's quite useful. First, let's try to understand what kind of numbers will have exactly 3 positive factors. Then there is a property as well that we learn in number properties. You can watch my video on the number properties and see the property that if the number is given in the form of a to the power p, b to the power q, c to the power r, etc., where a, b, c, etc. are distinct prime numbers and p, q, r are their respective powers, then the number of factors is given by p plus 1 times q plus 1 times r plus 1, etc. So we could have started this question like p plus 1 times q plus 1 times and so on should be equal to 3, which is possible only when 2 plus 1 is equal to 3. This 2 plus 1 confirms that a prime number with power 2 only can have 3 factors. So let me write a prime number with exponent or its power 2 will have 3 factors. So now we should have looked at like 2 square, then 3 square, then 5 square, then 7 square, then 11 square. All these numbers will have exactly 3 factors, but since the question talks about the numbers from 1 to 16 inclusive, so these two numbers only satisfy the condition. So only 2 numbers satisfy the condition. Answer becomes option B. So that's how we can answer this question in 2 ways. In fact, from the first method as well, you can just make an observation out here that the commonality between 4 and 9 is that they are squares of a prime number, and therefore they have 3 factors. In fact, all the perfect squares only have odd number of factors. But in case of odd number of factors, there may be 5 factors as well. Since the question was talking about exactly 3 factors, so it has to be the square of a prime number essentially. Thank you so much for watching the video, and please keep watching my videos. Thank you.